Thank you for your time today to join the Endress Hauser online seminar for the Promag W. This is the full bore electromagnetic flowmeter without inlets and outlet runs. But before I go to that, you can also see on my screen that the one with introduce you about the how to say our virtual exhibition. Currently, because of pandemic, we cannot go to have meet you physically on the real exhibition. Instead of that, we already developed the virtual here, and you can see that is a lot of information and a lot of the booth that you can interact with this one, and also the information on our booth. So in this slide, you can see this link that you can use this one for go into our booth, and from there you can explore more. So in the end, if we have time, I can show you a bit about this virtual booth. Okay. And so let me introduce myself. My name is Linh Trần. Trần is my family name, and I have the engineering degree in chemical technology and also the master degree on the petrochemical technology. I joined Endress Hauser since 8 years ago, more than 8 years ago in April 2013. And from then to December of 2017, I act as the business development manager to work with our authorized distributor across about 13 countries to take care for all the industries and the products, also the solutions. Since beginning of 2018, I work at the regional food and beverage business manager to take care the food and beverage industry in Endress Hauser and for we call the Asia Pacific Support Center region. Okay, this is my brief history about working in Endress Hauser. So the starter come here with the first one. I would like you to take your phone or your laptop as well with the internet connection or the 4G or etc. You please access to the website www.menti.com, and you can put the code 19450562, or you can directly scan this QR code on the screen, and then you can go directly into the the audit questions. Okay, so now I will show so the code, I repeat again, 19450562, or the order code. Don't worry, I will and now I change to the Menti, and then you will see the code again there. So just give me 1 second. Okay, I see already coming some answer. How many percentage of electromagnetic flow meter used in your plan? Just estimated. I just want to know that how do you see on your plan the percentage and how to say the population of your electromagnetic. This is quite common use magnetic flow in almost the industry, especially for the food and beverage, water, wastewater, etc. Okay, today we have and also one more thing that I see now we have around 95 participants, and you can write your questions into the chat into the menu of the GoToWebinar, and then we will have the person, Mr. Thak, is now on air with me, and he will try to collect this, and I will answer the question when we are in the end of my presentation. Thank you for that.
Yeah, it's my pleasure to support.
Okay, thank you. Okay. So now I hope that we have 95 percentage, but just 10 people to attend the now 11. So please attend this. This is also just an estimation. You don't need to do anything about the exact calculation. So we have about 10 seconds and we move to the next ones. So currently I see now the most contribution would be from 20 to 50% of the electromagnetic you are using in the plant. Yeah, this is quite numbers, and this is quite common in across almost the factories. Okay, so 5, 4, 3. Oh, sorry. Just a minute. Just wait a minute. I need to change this a bit. Okay. Okay, so now I move to the next question. Thank you very much for your first one. So the majority contribute in the 20 to 50%. Very good. And the next questions: which function or design you would like to wish to have in the electromagnetic flow meter? So anything you like for the new function to be added in, the new design also. So just type in your smartphone or your laptop freely. I see one person had raised their hand, but maybe we can talk later when we finish the webinar. Okay, thank you for that. Okay, I see some already respond. Half fill, yeah, okay. Normally electromagnetic require the full pipe, but if you have half fill, you would like to have this. Okay. Half fill pipe again, no installation requirements. Okay, maybe can understand that no inlet or outlet run required. Integrated pressure measurement, no need for external pressure components. Okay, it makes sense. Micromag, yeah, this is for the very small one to use on the maybe utility, as I understand correctly. And Endress Hauser, we have the Picomag, can fulfill that one for the utility with the very small one like the pocket size, strong anti-corrosion, and big LCD. Okay. We will have also something like that in near future for the big LCD as well, but not this one. The other transmitter type, anti-corrosion, you can have anti-corrosion based on the electrode selection and the liner selection. We also have almost liner material and electrode material can fulfill almost the application for not only corrosion but abrasion and other things. Okay, antibody detection, minimum strike run. Yeah, antibody detection we also have in almost our electromagnetic methods. And minimum strike run, there you come to the point. Yeah, we will come into that as well today. For the half fill pipe, we also can do this when we do the reduced bore. So electromagnetic, you know, normally they are full bore, nothing inside. But if you have the low flow, can create the phenomenon that for only the half pipe fill, and at this point create some not accurate. So we can use the reduced bore, and in Endress Hauser we also have that, which also not require any inlet and outlet runs. But today we will talk about something more than that. Oil product, wastewater treatment, chill water, boiler water, condensate, city water. Yeah, sure, almost we have application for this kind of water. except the oil product. If the oil product only and the conductivity is quite low, so the electromagnetic cannot be used. You have to change to another one like Coriolis or the vortex or the ultrasonic, etc. Wear resistant, yeah, also the same for the anti-corrosion operation. No installation requirement, yeah, you like to put there and forget it. Okay, to become to that. Measure volume flow, yeah, this is measure for volume flow in the beginning. So you have this is the primary variable to measure volume flow. Okay, partial fill by like before. Clamp on. This is somehow very interesting, but mostly we do it on the ultrasonic. But matter normally we use inline or somehow we use the insertion only. We need to be something to be intrusion into the pipe first. Okay, minimum straight run. Okay, no preferences. I not understand well about this one. Strong anti-corrosion. Okay, it's quite numbers of requirement. Thank you for that. And I think now we can come into now our presentation, and you will see if we can reach your expectation or your wish today. Okay. Now I will change to my presentation. Thank you very much for your answer. And now we will go to the next one. For the first one, I would like to come back for the electromagnetic principle. All of you may be known about that. You already known we use with a conductive liquid with the ring with the blue and the red color represent for the plus and minus electron. Okay, and when we have the coil with the electromagnetic field, and then the electrode like this, they will separate two minus and plus electron inside, and then they will create the voltage difference. And depends on the velocity. From there, they will measure the velocity inside the pipe, and together with the diameter inside of the device, then the electromagnetic can calculate the volume flow of the device. This is the basic, and this video is already available in our YouTube website. Okay, so this is a very basic one, but with the electromagnetic, this requirement in the installation is you cannot install them directly after the band or any extrusion, and they need a certain pipe length. We call the inlet run in the first one and the outlet run in the behind to require and to achieve the sufficient flow profile to make the measurement become possible and the accuracy is acceptable range. So with electromagnetic, we need the sufficient inlet and outlet run to make it be possible for the measurement. Okay, and also the accurate measurement. So that's why you need at least 5 dN in front of the device and 2 dN in the outlet. So this is the inlet run and this is the outlet run requirements. But with this, we have the challenging, sometimes challenging. If you don't have enough space, what should we do to achieve the accuracy? So one of the solutions is we reduce the bore of the device so that we can reduce the swelling and we have the better flow profile. And if you have the low flow, reduce pore is one of the solutions, but it's create the pressure loss. Okay, and in the skid or in some process, the pressure loss is also lost, mean that you need the more powerful pump. This is the problem as well for the electricity, and also you have to buy the bigger pump. Okay, it's affect to the capex. So there is the new solution. We come with the new solution like you see on the screen, the slide number 9 right now. that the device which is full bore also design, and this is the first and only electromagnetic flow meter combined with zero inlet and outlet runs with full bore design, independent of the low profile. Okay, and you can also, this is no restriction on, almost no restriction on installation with the band and insertion as well, that you can mount directly after that. So no pressure loss as well, and you can directly after band T15 insert device and so on. Okay. So the Cornerstone, the technical spec of this one. Let I check again if we have any problem right now. If not, okay, everything is good right now. This is Cornerstone for the, yes, technical specification. We have the, for the flange project connection here, both for welded flange and lap joint flange. Nominal diameter from the N25 to the N300, and we will launch also up to the N900 and more than that in the future. The liner material, you can use the polyurethane, the hard rubber, BTFE. For the transmitter, we use the new Proline transmitter, 3, 4, and 500, and it's a new Proline. Inlet outlet run not required, and the maximum measure error directly after the band is 0.5% of rating is the reference condition. Okay, and the design of sensor is not much too different to the Promag W sensor standard, but we have the multiple electrodes to be analyzed the signal from the disturbed profile. So for the N20 to 65, that we have 4 electrodes, mean 2 pairs, and the N80 to the N300, we have 6 electrodes, mean the 3 pairs, to analyze the flow signal. So that's why you don't need any inlet and outlet runs. Meanwhile, also maintain no pressure loss. Okay. So this function and this performance is already tested and already approved by the external and independent test center (NEL), and we reached the expected performance. This is the picture in their test center, and this is the certificate update calibration for our new Promag W 0DN and full bore design. Okay. So some pain point, you have the disturbed flow profile downstream of the bands, like you see like this in a narrow space, or you have some insertion device like level switch or like temperature device. Everything here can disturb flow profile, but with Promag W it is okay. 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 Yeah. Next one. If you have also inside the pipe something, now I am in the slide 14. Hope you are already with me. We have any sticky buildup or something like slurry or anything else stick into the pipe side here, and they can reduce the inside diameter of the device of the piping, and as well as they can create a disturbance to the flow profile. But with Promag W, you can use this one. Or another example is if you have the difference in the inside diameter of the pipe and the spoon piece. So with Promag W, this is no problem. As well as for the T15, the T15 is also the one of the thing can create a strong disturbance on the flow. And with Promag W, you can use it directly after the T15, as well as some kind is happen for some misalignment of the ceiling or the O-ring. That means that you don't have, they perfectly fit inside the flange, but they are protrude a bit into the inside diameter. So it can also create the swirl flow. Okay, so you can use in this situation with our new Promag W here. Okay, So this is some briefing point about our electromagnetic. Now, just wait a moment, don't leave anywhere. I'm not finished yet. We have also one more thing to show to you about this product. So this is another wide range function feature that saves your time and cost. First one, Webserver. I hope you heard about this with our new Proline 3 and 4 and 500 that you can use the Webserver to connect to built in our device, and you can use either the LAN cable here for the point-to-point connection, or you can go into the switch point here and you can connect many devices via the LAN cable, and you can connect to the laptop directly, and you just use the web browser software already in your laptop like Chrome, like Internet Explorer, Firefox, etc. And you put the IP address of the device into your browser, and then you can go directly to do the configuration for device. You don't need any software to install in advance. Okay, and it works with almost the communication part, Profibus, Anderson Filbert, etc. And other, if you don't like to use this cable, you can use also the option Wi-Fi. So with this one, you can use your mobile device, smartphone, tablet, and laptop to wirelessly connect with the device directly, and also use the web server to do the configuration. It's very, very easy. Okay, actually, you can use the traditional way with the put button in the device transmitter, but it takes time and it needs a bit of the patience. Okay, but with this one, it's very intuitive. I can show you later. And the next one, we have the wide range power supply. Means you can use either DC voltage from 24 volts to up to 330 volt AC, either. So you don't need to select the option for that. If you have one device in non-hazardous area, you can use DC or AC for them. No problem at all. Except if you use in the hazardous area, explosion area, you have to specify this device you only DC or this device only AC. But non-hazardous, whatever power supply type you have, from 24 to 230, you can power on this device. Okay. Configurable I/O. Now I'm in the slide 17. If you're not here, just let us know. So the configurable I/O here is also the special thing that we implement in our 3 and 500 device. That means with analog output, now you don't need to change any physically I/O board anymore. For example, if you like to change from 420 milliampere output to become the pulse frequency output, before you need to change the card physically, open the transmitter, change the card, pull out the old card, put the new card in. But with the configurable I/O, you can use only one card like this, and this is called a multifunction I/O as well. So you can change the type of the analog output or input directly in the device menu. For example, firstly, you set this 420 milliampere output, but then you want to change to pulse frequency. You don't need to change the card, just keep it like this. You don't need to open the transmitter, no. You just go to Webserver, the easy one, to change the output from 420 milliampere to pulse frequency in the drop-down menu. Okay, you have 4 possibilities and you can change one by one. Only one use in one time, but you can change to use. Don't need to use any other additional card. It reduces the stock as well. You just keep the same card on the stock. Okay, very convenient. And public technology, this is the one I will use later, and also the new come up one with the build-up detection, also implemented in our Promag W. So Webserver, this is for intuitive configuration. Now I'm in slide 18. Let's see if anyone got problem about that. Okay, so seems everything is nice, nothing problem anymore. Okay, cool.
Yeah. I think so.
Yeah, yeah. I hope everything is okay right now. So this is the how to say the interface of the web server. So I'm running this one on the Chrome, but you can run on Internet Explorer, can run in the Firefox, and you just put the IP address. The IP address will be shown behind the transmitter covers, and you can see that all you can see in the document. It's normally is 192.168.1.212. You don't need to remember that. You can show it in the device technical information as well. So when you put into the IP address and you go to the put the code default is 000040, and then you can log into the configuration page like this one. And from here you have measure value, menu, instrument health status, data management, and the network. And from the menu, you can go to setup or diagnostic or the expert or operation, very easy. You can set the language as well here in the main menu. Very intuitive and very easy to use. Don't need any additional software. Okay. Next one, heartbeat technology. This is actually I had before the also online seminar for that for last year to talk about this innovative function. This is heartbeat technology for our device health monitoring and also for the predictive maintenance. They have three main functions. The first one is the diagnostic, so means that the heartbeat will diagnose and checking your device 24 hours, 7 days, and they will show all the device status. We are the simple, like you said, like this. Is device okay, failure, our spec, or maintenance required, our spec, yeah, function check, something like that. And this is the according to NAMUR NE107. This is the international standard for the device diagnostic. Okay. Secondly is the verification. This is also the special function that you can run the verification for your device for this Promag W in particular, and without interruption to its operation, means that the device still operate, still send the signal, and you can also do verification in parallel. You don't need to stop the process, don't need to stop the device. Okay, everything is built in, and it's also certified by the third-party TUV for the operation reliable of the heartbeat technology according to the ISO 9001 standard. More detail will come up. If you have any question on that, contact me and I can give you more detail on this one. Okay, and the third function is monitoring. So with the help of the communication protocol like Profibus, like production field bus or HART or Ethernet, that you can the heartbeat can output all the monitoring parameter of the device to your control system, and from there you can see the real life trend of the device parameter. For example, the temperature of the transmitter. Somehow we don't care about this, but because flow, we care about the flow rate, totalizer, etc. But the temperature of the transmitter also play important roles for the device health, because the transmitter electronic board, because they are the electronic part, they cannot survive if the temperature is too high. Normally 80 to 85 degrees C, this is the maximum. So if anything happens, you have a short of the temperature inside the board of electronic, it can kill the electronic device, and then no power supply, no output anymore, and your device already needed to replace. And if it happens during the night time and this is a critical devices, this is a big problem for you, right? So with the help of the heartbeat monitoring, it can help you to see the trend of the critical parameter, and you can predict in before that, okay, this is fine, you need to do the maintenance, we need to check it in advance before it's breakdown. especially for the important and also the critical device in the plant. And especially for this also Promag as well, because you use normally like previously 20 to 50% of the device of Promag of electromagnetic in your plant. So this will play a vital role there with the heartbeat technology. Okay. And the new one together with the heartbeat as well is the buildup detection. So you know that somehow our device to measure some water like this in mining or in somehow with much slurry, so they can create a buildup inside the pipe with the thickness like this. Okay, or this is the view. This one is for the buildup, and when they create a buildup like this, it can reduce also the full bore, and also somehow they can stuck with the signal, cannot measure correctly, perfectly anymore. So normally currently now we don't have the person in the plant, you hardly to know how much or how is the condition of the buildup here. You normally to do by the timely or maybe depend on the process, maybe 6 months, maybe 1 year, or with 3 months, you have to unmount the device and to check and to clean the device. So somehow it's create a lot of the effort, maybe too soon, maybe too late to do that. You don't know. So we launched the new one we call the build-up detection inside together with the heartbeat technology for monitoring. So this is belong to the heartbeat technology, okay? And then they can show you now the build-up index by percentage. So please note that the build-up index from 0% to 100%, but it doesn't mean 100% the full pipe is blocked. No, this is show you the situation and the trend, how's the buildup develop inside your pipe. And if you want to know the buildup thickness, you need to also firstly to double check the device. If you see here about 20%, so with your normal maintenance, you know already how much the thickness you should clean it. So then you unmount the device and you check if the thickness there is already reached the normal value. If not, you can let it run a little bit more, and until you check if the buildup already reached the maximum device or reach the warning device, then you take it as your maximum level. Okay. As actually in our device, we can set the threshold for that. For example, we set about 50%, they will run in the alarm. But for you to easier to check, yes, first time a little bit time is needed more to commission this one. But when it's already finished, then this run very smoothly, and then you just set the alarm about, for example, you see 40% already reached the limit of the buildup thickness, then I set is 40%. And if you run the same fluid here, every time it reaches 40%, they will show you the alarm, and then you know, okay, this is the time we need to do the cleaning or etc. Give you more easier time and predictive maintenance to prevent any blockage more than before. Okay. So this is the finishing of this presentation about our device, the Promag W full bore 0DN, and also with other features I already presented to you. Thank you very much for your interest, and any questions? Okay, I also see that there's one question from Glenn, that this new model, when it have the same accuracy with the model who require straight by run. Yeah, this is two cases will be happens. If you choose this new model and you install at the edit file and 2DN for the electrons like normal case, the accuracy is still secure. Okay, that's it, of course. But when you don't have the inlet run, you can put it into the very narrow space 0DN, and then we can also they can also reach the plus minus 0.5% in the reference condition. Normally, with the straight by run required, already 0.2 or 0.5 is normal. But with the zero inlet and also full bore, no pressure load as well, we can also achieve the 0.5% in reference condition. Okay. Okay. The next one. Okay. Yeah. The presentation. I will give you by PDF after the webinar. There will be also the email to you, maybe 1 week. Okay. Quick liquid can be measured other than water, like gasoline. This is the electromagnetic we use only for the conductive liquid, only, no gas, no conductive liquid, because the gasoline is the non-conductive, so you cannot use the electromagnetic to measure that. You have to use another principle. We have also like Coriolis, like ultrasonic, like the vortex. Yeah, you can use that one to measure the gasoline. But the other liquid other than water but conductive we can also measure. It's like the milk, it's like the chemical, like the base, like other additive which can have the conductive liquid more than 5 microsiemens per centimeter. We can all measure that. Okay. Yeah. Does the flowmeter has the X version? Yes, they have the X version, but at that point you cannot use the wide range bubble supply. You have to choose either DC or either AC voltage. Okay. Yeah, I can. Hello, how can we get the slide? Yeah, I can ask that before. I can send the document later. The recording also, I could not follow the whole webinar. Can the recording be sent afterward? Yes, will be sent afterward on the email. Okay. Let I check first. Yeah. Again, another request is can send a seminar note. Yes, I can send the document later. The next question: does the flowmeter has input for pressure and temperature transmitter for standardization purpose? Actually, for this device, we don't have yet the temperatures inside, and also the pressure not yet have input into this. Because normally for the liquid conductive liquid, and this is not, and we use this one for mostly volumetric measurement, so the pressure and the temperature transmitter somehow is not play so much important roles here. Actually, somehow you need to know the temperature and but the conductivity we give into this device so that you can have the conductivity of the fluid at the measured temperature. Okay. Can this flowmeter be used for custody transfer purposes? Yeah, for the device a Promag W standard means you need the inlet and outlet runs, or you have the reduced pore that we have. That's one. We have the OIML 049. That is for custody transfer in the water base. But for this device, we don't have that. We don't use this one for the custody transfer application. Okay. Is there any increase in PFA thickness? This device, we don't use the PFA liner. We use only the BTFE liner. It is sufficient for the water-based application, not to abrasion or to corrosion when we need for the chemical. For the chemical, we have another device to use the PFA liner for that. And I don't think, and then I need to check for the thickness of the PFA liner, but I don't think it's increased for that. if I understand your question correctly, if you mean about the BFA liner. Okay. The next question is the tolerable error same from 0.1 meg per second to 10 megs per second. Yeah, it is not the same because it depends on the when you have the low flow, the accuracy is we not good. This is all for all the device. So then when you reach the certain velocity, then the already flow, they give a little bit more profile, much better, and then you can get much better accuracy. And with the 10 meg per second, you also can get the specified accuracy. Okay. The question, can we order 600 mm at the special version? Yeah, as I understand right now, you can order the DN900 version already, but I need to check on that. The first release until DN300 only, but as information I have, they already released for DN900, but we need to check again. Yeah, but it's possible and up to maybe more than 900, but it will be the second package. Yeah. Next question, what is the expected accuracy if installed at the tie bands? Yeah, if installed at the tie bands mean that after the 90 bands, then also if the 90 band, and I understand you correctly, as is also plus minus 0.5 degrees C in the reference condition. But in the real life, we need to check also maybe the error would be more than that. This is because of the another effect like installation, like the condition, temperature, the humidity, everything. Yeah. Okay. They have a bit more question. I think that because now the timing also going down. Sorry for the very first technical problem. So the rest I will answer you via the email, and I will send to all of you about this. I hope this is okay for you all. Right.